All right, so class activity 2M is not one that's a core activity, but I would like to go through the solutions here just so that we have seen how this kind of thinking can be used on the number line. So for example, we're given a number line in question 1, and we're asked to plot 3/4 without first plotting 1. So what we have right now is we're looking at thirds, and we want to be able to plot quarters. So is there a number of pieces that we could use to fill the hole so that we could look at thirds and quarters? And if you remember, 12 was a really good number for that, because 1/4 of 12 is 3, and 1/3 of 12 is 4. So if we could find what a 12th is, then we would be able to plot 3/4 without a problem. Well, if we have 2 1/3, we can plot 1/3 right here, because it would be partitioned, the 2 1/3 into 2 pieces, and we have 1 1/3. Now, if we want 12ths, then we would have to take a 1/4 of that, right? So 4 pieces would have had to fill a third in order for 12 to be needed to fill the hole. So these are 1/12. So we can do the same thing here. And then now let's look at where 1/4 would be. Well, the 1/4 is how many pieces of 12ths? Well, it's 3 pieces of 12ths. So this would be 1/4 right here, and we need 3/4. So this would be 2/4, and 1, 2, 3/4. So notice that we weren't working towards 1 and then repartitioning. What we were actually doing is looking at that smaller distance, smaller unit fraction that we could use to represent a third and a quarter. So for number 2, 3/5, we're going to be looking at fifths and halves. And what's a nice number to split 1 into in order to be able to find a fifth and a half? Well, if we were using 1/10, then 1/5 of 10 pieces to fill the hole is going to be 2, and 1/2 of 10 is going to be 5. So if we use tenths, then we should be able to find both halves and fifths. So let's see, this is 1/2, and 5/10 would be the same as 1/2. So let's see if I can draw tenths. 1/10. Now, if we need 3/5, 1/5 is 2/10. So this would be 1/5. So that's 2/5, and this is 3/5. So notice again, we didn't go into to figure out the whole. We actually went to figure out a small unit fraction that could be useful for looking at fifths and halves. So let's look at number 3. We want to look at 8ths and 6ths. Well, 8ths are not a good number to look at 6ths, but let's try 16. 16 is not a very good number to look at 6ths. How about 24? 24 we can look at 6. So 24, we know 1/8 of 24, right? And we also know 1/6 of 24. So 1/8 of 24 is 3, and 1/6 of 24 is 4. So 1/6 of 24, if we needed 24 pieces, if we're looking at 1/24, we need 24 pieces to fill the hole, then 4 of them would represent 1/6. So this is our 1/24. Now, if we need 3/8, let's see, what's an 8th? If the hole is 1/24, if the hole is 24 24ths, then an 8th is going to be 3 24ths, or 1/8. And we need 3 of them. So there's 2/8, and there's 3/8. And notice again, we were looking at a common unit fraction here that we could use in order to see both eighths and sixths. So let's see number 4. Number 4 is slightly different. So far, Sue has run a quarter of a mile, but that's only 2/3 of the total distance she will run. What is her total running distance? So Sue has run a quarter of a mile, but this piece, this quarter of a mile, is 2/3 of distance. So in fact, what we actually have is we have another number line of the distance where 0 of the distance is here and 2/3 of the distance. What she ran is actually 2/3 of the distance, and we need to figure out where the total distance is. What is her total distance, running distance? So if this is 2/3, it's 2 pieces, each one of them is 1/3. So that's 1/3 of a distance. And then if we take 3 of those thirds, that's going to be her total running distance. Okay, so we want to get to here. We want to find out what that is in miles. Well, how did we get there? What is half of 1/4? We cut 2/3 in half, right? We did 1/3. We got 1/3. So half of 1/4 is 1/8. You need twice as many of them to fill the hole. So this would be 1/8, 2/8, and 3/8 of a mile. 3/8 of a mile is her running distance. So notice that we are looking at a double number line. One of the number lines is actually measuring miles. The other number line is putting that alongside of the total running distance, measuring running distance. You will see this kind of setup in lots of different places, including multiplication and division, and then eventually proportional reasoning in 114. So let's try to look at another example of this in number 5. So far, Tyler has run 2/3 of a mile, but that is only 3/4 of his total running distance. What is the total running distance? If we use the double number line, and this would be running distance, 2/3 of a mile is 3/4 of a running distance. So let's see what it is that we want to figure out. So 3 1/4. So we want to partition that the distance that he ran into the quarters, because we have 3 of them, and figure out where the total running distance will be. So this is our total running distance. So this is what we want to learn in miles. So if we had 2/3 of a mile, I wonder how much this would be so that we could figure out what a quarter of a distance that he ran is, and then we could figure out what the whole distance is. So if we have 2/3, there are a few ways to approach this. One is to say, all right, well, if I have 2/3, I can figure out what 1/3 is. So I partition that into 2. Now, this is 1/3 of a third. Sorry, 2/3 of a third. So we can partition the third of a mile into 3 pieces. Then each one of these pieces is actually a 1/9. Because if you need 3 of these to fill the mile, then you will need 9 of these to fill the mile. So if that's 1/9, so this is 1/9, this would be 2/9, 3/9, 4/9. All right. We could do 5/9, 6/9, and 7/9, and 8/9. So that would be 8/9 of a mile is the total running distance. Oops. 8/9 of a mile is the total running distance.